Hi guys, welcome to section 10.1. This is day 1. We're talking about sequences, series, and sigma notation. So today we're going to start off with sequences. The sequence is just an ordered list of numbers. So typically a sequence has a pattern to it. Sometimes it does not. Two common patterns that we talked about in class today were arithmetic and geometric. Each number in our sequence is called a term. So this is first term, second term, third term, so on and so forth. We could either have a finite number, which means just a set number, like this one has a finite number of 6 terms, or we could have an infinite number of terms, and that's when we put this dot, dot, dot underneath it, which means it keeps going on and on forever. We have 2 different ways of writing an equation. One is an explicit formula, and one's with a recursive formula. We'll talk about that in a minute. Notice here, this is your first term of the sequence. A sub 2 is the second term of the sequence. A sub n is the third term of your sequence. A sub n is the nth term of your sequence. In other words, you can plug anything in for n and find that term. All right, so here's our first sequence. It says find the next 4 numbers. So when we look at these numbers, they appear to be going down by, it looks like 4 each time. So 3 minus 4 would be -1, minus 4 is -5, minus 4 is -9. If I subtract 4 more, I get 13, -17, following that pattern, -21, -25. This guy, because I'm adding or subtracting, in this case subtracting, is called an arithmetic sequence. It's spelled the same way as arithmetic, but mathematicians say arithmetic in this particular case. And it's got a constant change. Oh, and the graph of an arithmetic equation, arithmetic sequence, is going to look like a line in this case because it's decreasing. If I were to plot all of these points on a graph, it would look something like that. All right, for our next sequence, we got 81, 27, 9, 3. I think a lot of gut reactions yesterday was like, oh, it's the cube root, it's the 4th root. That was my gut reaction too, because we just came out of exponentials. But on a second glance, if you look at it, we're just dividing by 3 each time. 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3. 3 divided by 3 would be 1, divided by 3 is 1/3, divided by 3 is 1/9, divided by 3 is 1/27. And so when you're multiplying or dividing each time to find your new term, it's called a geometric sequence. And geometric sequences, when you graph the points, take the shape of an exponential function. Let's see if I can do a little bit better job. This case, because it's getting smaller, it would be a decaying exponential function. We wouldn't connect the dots, but there's the geometric sequence if we were to graph this guy. All right. Find the first 4 terms of the sequence given by the explicit formula. A sub n is n cubed plus 1. All right, so first term is 1 cubed plus 1. That's 2. Second term is a sub 2. That's 2 cubed plus 1, 9. A sub 3, 3 cubed plus 1, 28. And a sub 4, or the 4th term, 4 cubed plus 1 is 65. All right, so those were, this guy here is defined explicitly. In other words, when I plug in 1 to find my first term, I just plug it in here and it tells me what the first term is. Super easy. Explicitly defined sequences are real easy to find your terms. There's another kind called recursive formula. In order to find your terms for a recursive formula, you have to know all the terms that came before it. And so I will talk about that in the next video.